Chapter 3, like the other chapters that we've been studying for so far, has some study of transformations, and this one's no different. We're going to take a look at a couple examples that involve exponential functions and how the transformations can show up there. So a reminder as to what the transformations we're looking for are: the vertical and horizontal shift, the reflection over the x-axis and the y-axis. The y-axis one will actually come into play a little bit more often in this one. You'll see it from time to time. There's vertical stretch and shrink, and then there's always the one that I make special mention of, and that is horizontal stretch and shrink, because that one is just weird. It's not nice. It's got this form x divided by a, or we talked about it before as f of x divided by c. So it's always got to be in that fraction format when we're talking horizontal stretch and shrink. So we are going to take a look at a few examples. Here are the examples from our notes that we'll see today. We're going to do some transformations on those. And now before we even do that, I just want to make note of the fact, or just point out to you that the exponents, I like to think about those as being within parentheses. So whenever I see an exponent in at least this section, I'm going to put parentheses around them, because that's going to tell me where I start with my transformations. I'm always going to start within the parentheses here, and it's going to make for a few different transformations. So going in order, as far as the transformations here, let's start with this one. Number 1, we have x minus 3 on the inside. Now we're doing the opposite of what we would think. So remember, that means that we are going right by 3 as the first transformation. Then we're going to work our way out. Now e to the x is the parent function, so we don't worry about e. We next worry about the 4. Anytime you multiply outside an equation by a number, it's going to be a vertical stretch or shrink. This is going to be a vertical stretch by a factor of 4. And then we have one more transformation left for this one, and that is the plus 5. That's going to mean up 5. All right, now on to number 2. Probably need a little bit more space for the other ones, but I do have that on another sheet. For number 2, the thing to really notice here is that we've got 2x. We've got something multiplied by the x, and that is going... So since there's this 2 in front of the x, that's going to have something to do with the horizontal shrink, because if you rewrite 2x, that's the same thing as writing x divided by 1/2. So what that means here is, for this problem, we're going to have a horizontal shrink by a factor of 1/2. And that's a little bit counterintuitive, but that's just kind of the way it goes on this one when you have the 2 being multiplied there. Now, for the other part here, you'll notice we have 2x plus 1, and you'd be tempted to think that it's going to be left 1, because usually when we see plus 1, it's left by 1. Now, you're close if you're thinking that, but here's the catch. We need to, if it's got a 2x plus 1, we got to figure out what makes that entire thing equal to 0. That's going to tell us left or right, and so then we're going to be solving this one. So I subtract the 1, divide by 2, and x is going to be equal to negative 1/2. So it's not actually left by 1, it's left by 1/2 in this case, and that's a little bit of a twist on things. So it's left by 1/2. Now I'm going to use a new page for the next one. So now on to number 3. Number 3 only has one transformation, so that transformation has to do with x over 2. Remember that the horizontal shrink and stretch is just automatically in that format, so there's really only one transformation here, and that's going to be a horizontal stretch by a factor of 2. So that one's kind of nice. That's just a real simple, quick problem there. The last one here involves 3 different transformations, and I want to just point out this negative first of all. We haven't been seeing that very often on the x, but remember that the negative means that we're talking about a reflection over the y-axis. So that's one of them. We can start with that one because remember that the negatives along with the horizontal stretches and shrinks, those kind of are interchangeable as far as the direction we go with them. So the next one's going to be a result of this 3x, and kind of like we were saying for this last one, for one of them, that you do x over c as the format. So when we say 3x, it's like saying x divided by 1/3, which means a horizontal shrink by a factor of 1/3. So that is the second to last transformation here. The very last transformation is going to be related to all the stuff inside, and that is we're going to set negative 3x plus 3 equal to 0. Whoops. And then we're going to solve that. So subtract the 3, divide by negative 3, and x equals 1, which means it's positive. We're talking a shift to the right by 1. So lots of different things going on there, but with exponentials, what you'll tend to see is the horizontal transformations are going to be a little bit more emphasized than the vertical transformations in this part.